Good morning, good afternoon, good evening. Welcome to another episode of Hands-on SAP Dev with me, DJ Q Macro. Welcome everybody. Thanks so much for joining. I've got a little bit of a it's not new, but it's a different setup. So I might have to run out and get my emergency old setup. I've got to monitor the chat rather than have this second laptop, this Chrome OS device. I've got at the side, I've got my phone, and I thought I tried this out the other day. I watched a live stream on my phone on YouTube, and because the live stream was live, the live chat on the phone didn't disappear, and the phone didn't turn itself off. That was a problem before. I tried the phone. I was trying to monitor the chat on the phone, and anyway, for whatever reason, the phone kept sort of turning itself off, as in, going, on sleep mode or whatever. So if it does go on sleep mode, I'm going to have to go and get my emergency laptop and plug it in and everything. But I think it should be okay. Good morning to Javier. Ready to learn more from your unstoppable brain. Unstoppable brain. Oh my goodness me. I'm going to tilt this phone a little bit there so I can see it a bit better. There we go. Chiara, buongiorno to you. And Tim, good morning. Marianne, good morning. And Mikhailo, good morning to you in Lviv. And Helmut, good morning. Good, that's sort of Denglish. Good morning. Morning to you in Braunschweig. And Sudarshan, good morning to you. It's great to see you all. Absolutely fantastic. So yeah, we've got another episode 2 of the Let's Explore Functional Programming. I'm just slightly discombobulated because it's not usual that the chat is up here where the microphone is as well. I don't know whether you've seen that my sort of office setup here on the narrowboat. It's quite cozy and compact, but I've got everything. Anyway, let's carry on. And good morning to you, Raoul. Welcome. So. Yeah, it's a little bit of a continuation of where we left off, I think, last time. It wasn't last Friday, it was the Friday before last. Why wasn't it last Friday? Oh, yes, because it was Easter. And there's a couple of things I want to start with to go back to revisit a couple of little details that we went over and I sort of skipped over a little bit. So we'll do that. I also then want to start looking a little bit more into reduce. One of the details I want to go back up on from last time is a little bit about reduce and why, for example, I chose the names A and X for the parameters of the callback function of the Lambda anonymous function that we passed to reduce, which is a higher order function. I also want to try out reduce in a different context, outside the context of JavaScript, and I'll explain why I want to do that shortly. But if there's anything else you want to explore in sort of this area, let me know as well, because I also then, when I start, and this is, I was thinking about this morning, what do we want to do? And once we've done that, that will give us a chance as well, while we're in this other context where we're going to be trying out reduce. It's called Ramda. Good morning to you, Matthias, and welcome, which is a sort of a functional programming library for JavaScript. It gives us the opportunity to just put our little toe in the water to start thinking about partial application and currying. Remember, I went through a series of slides with just words on, like currying, partial application, composability, immutability, higher order functions, and so on, right? And I'll put my phone there so I can see the time. There we go, 8:04, perfect. And so 2 of those sort of phrases that sound a little bit sort of, very intellectual, currying and partial application. A little bit of a taster as to what those are, and we can dig into those a little bit more as we go through this series. Good morning to you, Raihan. Good morning and welcome. So let me switch to the main scene. And let me move to where we were before. I want to recreate, CDS REPL. Let's actually just start the REPL as it is. We don't really need the bookshop. Remember, this is what I've got here. Let me just finish that again. What I've got here is actually a clone of the Cloud Cap sample. In fact, Cloud Cap samples. There we go there. That repo, it's a great repo. It's a mono repo. Oh, see, our fearless leader, Daniel, has been hacking on this repo very recently. So this is the repo that I've got cloned. And what I did last time was actually CDS start the REPL and run the bookshop service, which is one of the many bookstore, orders, reviews, etc. One of those there. So that's what we did last time, and it started at the bookshop, and it gave us sort of, first level access to all these different things. Now we don't really need that, so just to sort of prove that we don't need that, let's start again and say CDS REPL. Okay, fine. By the way, oh yes, sorry, Sapvik, good morning to you. Raihan says, honestly, at first when I saw the title of part 1 of this video, I thought it was going to be UI5 related. Ding, but even JS flavor is helpful to understand all the pattern aspects of CAP. Yes, you know what, Raihan, it's a really good point. One of the things that I did share last time, and I'll just bring it up again anyway, is functional programming resources. A lot of the functional programming resources that I listed in this thing here, let me put it in the chat. Buongiorno, Kazati, sorry, my brain's not working, were related to UI5. Okay, so I did a lot of UI5 in the past, worked on the UI5 team internally at SAP as an external back then, and got involved in a lot of the JavaScripty stuff. So yeah, in fact, while I'm here, this reminds me, let me bring this up now. This reminds me, this has got, I remember on slide 30, I did have a look at this yesterday as well, slide 30, this has got a little bit of an explanation, which will hopefully I'll remember to go through with you when we start digging in a little bit more to reduce. And this sort of already, you can see here, this word here, accumulator and current value, this gives us an idea as to why I called the two parameters in the definition, in the anonymous function definition of our callback function for reduce, A and X. A for accumulator, X for thing, whatever. Okay. Anyway, that's that. In fact, I'll close that now. No, I'll leave that open. There we go. That's that. So I've also got Capira open, Capire, the documentation for CAP, because I want to explain something that we covered last time. DJ, stop rambling and get on with it. My goodness me. So what we'll do is we'll define a service like we did last time, and we'll add a before handler. Okay. In fact, one of the cool things that Daniel did, we'll do that as well. Good morning, good idea to you, Yavuz, and welcome. Is we'll define a service, and we'll define it sort of S. Let's call it S rather than my service. S equals new CDS.service. But because we sort of put that expression in brackets, that will then give it. In fact, no, let's not even go there. Let's just do that first of all, right? And then S dot before. Let's use the same sort of banana, event name, and then have a handler. And what we did was, well, we had 3 different types. I'm not going to go through it again, but we'll do this one here, console.log before. Let's put something in so we can sort of see it's coming from this log execution before X. There we go. Right, there we go. That's what we did. And then we said send banana life 42. That's what we did, right? Something like that. And then actually what we want to do is, of course, await to actually run it. There, and there we get, let me make that a bit bigger. There we get the before handler. Okay, we can see the before handler has been triggered, and it says before : and then X, which is whatever X was, which is this thing here, request open curly brackets method banana data live 42, right? Then what I did was I basically said s dot after and did the same sort of thing, banana, and then we'll say x console.log after. You know, I didn't put this after sort of colon prefix, but we can sort of see it now. X, right? Now, when I did that, so, okay, great, we got a before handler, we got an after handler. Let's make that call again. Let's send send a message to banana with this little payload life 42. Oh, there we are, done it again. Await. What happened was we get that. We get after undefined. Now, does anybody know? Did anybody think, DJ, you're an idiot? The reason why it's undefined is ... Well, partly the reason I didn't want to go into it previously on the previous episode is because I'd forgotten, and also I thought it's going to take too much time to dig in and blah blah blah. But I wanted to do that because I wanted to sort of, you know, leave no stone unturned. I don't think that's the right phrase, but anyway. Now, if we go and say before and have a look at before, we can see that in our CDS service, okay, we've got serve on, before, and after, right? Let's do that first of all. So on, before, and after, use these methods to register event handlers with a service, usually in your service implementations init method, right? Okay, fine. We'll have a look at before, and before, here's a sort of the function signature. Okay, we have 3 parameters that before can take, right? One is optional. You can see that with a question mark. Event, right? So our event is banana. Where's the before definition? There. Okay, there's our before definition. Okay, so there is the event banana. I didn't specify an entity. Okay, so the next one after that is the handler. Okay, now the handler is basically this, our Lambda function, right? Remember, before is a higher order function because it can take a function. It expects a function in this position. Marian Size asks, can I hear chickens? Actually, you can hear geese. They're outside. They're right by the duck hatch here. So actually, this window behind me is colored. It opens out like this. It's only the blinds are closed because the sun is shining in right now. Yes, duck sounds in the background. Yes, ducks and geese. In fact, I took. You see all my photos now, but I don't care. There we go. So in fact, that was out. They were outside the window this morning when I was having a look outside the duck hatch. So that's what you can hear. They are who you can hear right now. Think of names for these two. Anyway, so what was I doing? Oh yes. So this is a handler. Okay, and what does the handler receive? What is given to the handler when it's invoked? A single argument, which is captured in this parameter called which is request. That's why, by the way, that's why the first thing that is, you know, the wrapper description of what we console log out is the type of thing it is, right? It's an instance of the request class. Okay. Now, why don't we get anything with after? Well, let's have a look. After, serve after, event, banana. We didn't specify an entity, so there's our after. Where's our after definition? There we go. There's the definition. So there's the event. That is our handler there. Same as the before handler, but just with the word after, right? But the after handler gets not just the request object, but it also gets the results. Because remember, what is an after handler normally used for, or often used for? to enhance or otherwise modify the results of the actual request before it gets sent back out to the requester, right? So basically, the first parameter, and of course, I've only defined there a single parameter, x, right? So if I say, oh, I've just defined it. In fact, let's do that again. Go into the REPL, let's clear it out. What I'll do there, s equals, in fact, let's do that before banana result.log before x, and then also have that there like that. We can do that as well, right? We can sort of do it all in one go by sort of enclosing the expression, the sort of the instantiation of a new instance of the service class as an expression there, and have that, and then you can call before on it, right? And then I'll do an after as well. S.after banana there. There's after broken. Let's do that, okay? Because we know this is sort of broken. But now now when we send something, right? Await send banana life 42. Okay, fine. So far so good. I got exactly what we still got there. But now let's define a non-broken handler. Okay, a non-broken after phase handler. What we'll say here is, well, let's ignore first of all the first argument, which is this one, and then the X will become request. So that, I mean, that's a bit of a stupid way around, but that basically also starts us thinking about sort of multi-parameter definitions of Lambda functions, right? Okay, and underscore is like a convention. You know, I'm going to throw this one away. I'm not interested in it. And now, oh, I put broken there again. Never mind. God damn it. Send there. Okay, that's supposed to say not broken. But anyway, we get it. So what is this undefined all about? Well, if we define s.on, an on phase handler for banana, and just return something. Well, let's have a function, because it's expecting a function. We can't just return some sort of, you know, static array. Let's just return 1, 2, 3 like that, right? This is so random, right? But let's do that and see what happens. Now, what's going to happen? Check it out. Do we understand everything? Before is just the same. The broken after, well, it's sort of not broken anymore because it's returning something, but basically it's returning the value of the first argument passed, which is this one, which is the results of the actual handling, the main on phase handling of that request. So that's what we get. And so that's it. Does that make sense? Let me know if that makes sense. I didn't want to sort of leave this sort of weird, undefined. Why did we get something like that? Okay. So let me know in the chat if that makes sense. And by the way, this is just the general output. Oh, so I mean, what you would do. Let's do that again one more time. Let's do that. I'm going to here and let's have this new CDS service. Let's start from the top actually. Clear. There, where are we? There. We got the before, and let's do an s.on banana, and then we'll say if we, whatever, you know, that's the on banana. We're not specifying the entity, and we have the handler function, and that we can sort of, yeah, we can return a value on x. Don't really need x. Let's do that again like that. 1, 2, 3 like that. But now let's define an after function. Okay. Oh, wrong one. Let's define an after function. Say s.after banana, and then let's take the results. We're not interested in the request really now, so let's just take the results. Let's call it results. And then let's just say, let's just add another number on the end, right? So let's say results length results.length -1. See, in JavaScript, you don't have this sort of -1 thing as in the last one. But anyway, results oh, I'll tell you what I could do. Results.push. Results length, results length -1. Get the last one, add 1 to it, put it on the end, return results. This is a stupid thing, but anyway, right, there we go. Should we try that? And now say s.send banana. Well, it doesn't really matter what we send, does it? Let's just send an empty thing. Oh, await. And there we go. We get 1, 2, 3, and then 4 on the end. Okay? Silly. But hopefully, let me know in the chat. You're very quiet in the chat. Let me know if that sort of makes sense and you feel a little bit closer to these key methods, on, before, and after phase methods of the serve, of the service object. Anyway, that's that. The other thing I wanted to cover, let's go up here. Let's start up the, where is it? Oh, what's it called? Episode 1. There we go. Let's start up the REPL. There. This is where we left off, but we also had this. Example that I was saying. Const sum equals. Let's not use const. Sum equals ax a plus x, and then I was saying nums dot reduce sum. Okay, like that. Is that what I did? Let me know. Let's just send those. Nums is not defined. Oh, there we go. Let's send that as well. And then send that. 15. Okay, that's what we had. By the way, before we do that, let me just share this slide link here. Okay, there we go. Perfect. So, yep. So, now, 2 issues with this. One question and 1 issue. Sum, in terms of naming, maybe I should have called it add, because sum, if I go, for example, to Ramda and have a look at reduce. In fact, let's go to try Ramda. Right? Oh, in fact, no, sum. Here we go. Sum. Sum is already a well-known, a well-understood. I mean, Ramda is just an example, right? A well-understood function name that will add together any and all elements of a list. So not just 2 things. So maybe what I should have called my function is add, which will add 2 values. Okay, so it's a very, very subtle difference, but add. Oh, tell you what, is my language server installed? Maybe it's not. Have I got my JavaScript language server? You can't read them. Say, preparing them. Add. Never mind. I've been messing around with the language server client at the moment. So that. Okay, let's send that. That works as well. Oh, wait. You select. Okay. So Javier is asking what I'm doing here, I think. So if I say, for example, console.log hello Javier, I can send that to there, because that is that's a NeoVim plugin. In fact, if I say here nvim and REPL, I've got this REPL. So this is the REPL plugin. So it's on GitHub, so github.com papasam nvim REPL, and I've got some key definitions here. So if I'm in normal mode, for example, and I can hit leader, which is my spacebar R, it will send the line. Or if I highlight something, and I'm in highlight mode, I can send leader R and it'll send the visually highlighted thing to the REPL. So that's how it works. So in fact, Papa Sam, let's look at that. Papa Sam, let's send that so Javier can have a look. There. So that's what I'm doing. Hope that's okay. Javier? Okay, so now, so that's the first thing dealt with. But the second thing is, why are these two parameter names named as they are, A and X? It doesn't really make sense. You could have A and B. That would sort of make sense, right? A and B. That would still work the same, right? Or you could have, for example, X, Y plus Y. I mean, I'm going a bit mad here, but anyway. However, the reason I called the first parameter A is because of this thing here. Now, put in the chat, please, if you have looked or stared at, I think that's the right phrase, stared at what reduce is and how it works. Because I want to sort of go through this and make sure we understand reduce, because it will then become, like I said before, like a building block for other functions. I think down here, yeah. So here's an example. Again, I don't want to use the slides, but here's an example of where I defined a map function. Of course, the array prototype already has a map function, right? But you can define map in terms of reduce. What I said last time was that reduce is like the UR function. It's like the core building block of so many different things. Anyway, so let's go here. In fact, let's go to Ramda. Let's go to Ramda. Ramda, and go try Ramda. So let me share that as well. There. Const nums equals 1, 2, 3, 4, 5. That'll do, right? I don't like semicolons. Now, I'm just going to write it out first of all. Instead of this is a Ramda context. So instead of saying nums.reduce, because that is calling the reduce prototypical function on the nums array type, right? What we can say here is just reduce, like that. And in fact, if we have a look at the documentation on reduce, this is the more sort of non-JavaScripty generic definition of reduce. Okay, so Ramda itself, let's go to the home. Ramda is a practical functional library for JavaScript programmers. So what does that mean? It means you can sort of, require Ramda and then use Ramda facilities to extend the scope of your language base, your functional language base in JavaScript. And it provides functional programming mechanisms to you as a JavaScript programmer that you don't have out of the box with standard Node.js JavaScript, okay, or any JavaScript for that matter. So while JavaScript does have some awesome functional programming features in the form, for example, of functions like reduce, map, and so on, it doesn't have built-in other features like being able to query a function or being able to effectively, therefore, sort of, implicitly partially apply a function or compose functions together with explicitly. We'll do function chain. We'll talk about function chaining shortly. So Ramda is really cool. In fact, my son Joseph, whose birthday it is today, I was trying to get hold of him. I can't get hold of him yet. He solves advent of code in Ramda, using Ramda. Okay, so there, for example, there's a compose example, where he's creating a function by composing other functions. One function here happens to be an anonymous function, a Lambda function, but then there's a drop function and a match function provided by the Ramda library, represented by R here. Okay, so anyway, let's not even go there. So Ramda is awesome, and it's also a great way to learn more generically and more purely a little bit of functional paradigm, but still using JavaScript. Okay, so, and it also has a REPL, like a try it out thing in the browser. And the really cool thing as well is that if I, this is a stupid example, but let me just complete that there. Can you see that the way that the URL is changing? I can now save this and share this as a URL. Check it out. If you click on that, you will get exactly what I've got on my screen. Anyway, so let's think about reduce. Let's define, well, in fact, we've already got an add function, const in Ramda, add, and also in this REPL, the functions that are defined here are all available at the top level. When we looked at Joseph's Ramda solution, where is it there? Joseph was requiring the Ramda library and then having to use the normal sort of, library dot function to refer to them. But here within, for example, within the Ramda REPL, if you look at drop, for example, there, drop is a function, as you can see there. Okay, so we can also say r.drop as well, but drop is a function sort of natively in this REPL. Am I losing you all? Let me know in the chat if it's okay. Oh my goodness me. Right, let's, DJ, stop talking. So add. So add is also a predefined function. Where is it? Add. There. Okay. Number. Let's not go to these signatures yet. This is a very, very common thing in functional programming, in that you have this sort of type signature. Of course, those folks enjoying TypeScript will understand what this is, but we'll deal with that shortly, maybe another time. Visa's good morning. That's okay. It's no need to worry about joining late. We're so glad you're here. Okay, so we've got add. So if we say, for example, where is it? Ramda documentation. We need that. We don't need that. Let me get rid of that as well, and that, and that. Okay, right, there we go. Add 1, 2. Okay, we get 3. Can we make that bigger? Here we go. There, we get 3. So we've got this add function. So we can do the same sort of thing as we've done here. So let's do that now. Rather than though do this nums.reduce add, because that will give us 15. But that is the built-in JavaScript reduce that is part of the array prototype. That one, native code. Okay. However, what we want is to use the Ramda reduce partly to sort of learn on a more generic level, but also partly to, hopefully in a minute, stumble across a problem that we've sort of been avoiding because we didn't even realize it existed, but we can learn from that. That's the third parameter to reduce. Notice that yesterday I just sent a single argument, the function, this add function. Now, of course, there's an implicit argument sent to reduce, which is, of course, the nums value itself, as in the array, right? There. But really, well, let's have a look at reduce. Ramda reduce. This is the pattern. Okay, now, what do we want to see? Does this help us a lot? Yeah, so shall we try and read this bit? Here's the type definition of reduce. Doesn't matter if this doesn't make much sense right now. But basically, reduce takes a function definition that looks like that. Okay, remember A, B gives A, right? So that is effectively, that is a function definition that sort of conforms to that pattern. So that's our reducer callback. That's our anonymous function, our Lambda function, for example. That's our function that reduce will call successively each time it goes through one of the items in the list. It also takes a scalar value, A. Then it also takes, what's that? An array, square brackets. And then it produces something. Now that is super random and super sort of high level, but also like really intellectual at the same time. What that means in reality is we need 1, 2, 3 things to give to reduce, and reduce is going to give us a final thing. Notice also, and this is sort of a glimpse into a future episode, notice also what this type definition looks like with these arrows. Good morning. Oh, sorry. Javier, I was thinking Javier's been here already. So Javier, well done, Javier, for saying good morning to Visa. That's brilliant. The way that this is sort of written down is that it's sort of progressive arrow, 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 arrow. And that is all about, not all about, but that gives us a clue as to what partial application is or could be. I'm just going to leave that there. I'm not going to try and describe partial application yet. I'm going to show it. Here's an example, right? Just bear this in mind. So, in fact, can I put that on the same screen? Ooh, yes, there. So, on the same screen, we've got this thing is this r.subtract. So, subtract is also a built-in function into Ramda. Okay. In fact, let's open up the documentation, Ramda, and look at subtract, just so we know what it is. Subtract subtracts its second argument, it's easy for you to say, second argument from its first argument. So basically, if we do that, subtract 10, 3, we get 7. Okay, fine. So subtract, so there is our function that takes 2 arguments and returns something. So 10, 7, or 3 gives 7, right? The next thing here is this thing here. Can anybody tell me in the chat what that is and why it's called A? I mean, it's the clues in the text here, but anyway. And then the third argument that reduce is expecting is this thing here, which is, as it's shown, an array of things, the things over which it's going to iterate. Right. So enough theory. Let's jump to here and say, for example, we'll write it out, we'll run it first and then go through what it means. Reduce, add. So Javier's got it. Thank you, Javier. Exactly. A is the accumulator. Now, bear that word in mind in a second. Add. Now, if we were to try and sort of reproduce what we have here, where we're passing in this function, and this happens to be not an anonymous Lambda function, but it's a function that we've, it's got a name, right? And sort of implicitly through the prototype way of calling this reduce in pure JavaScript, Node.js JavaScript, we're giving it this array of numbers. So let's give it the numbers as well. What happens is that it's giving us something that's not expected. We're not expecting this. We're expecting 1 plus 2 plus 3 plus 4 plus 5 is 15. We're expecting 15. So why are we getting a function? That is another clue or another glimpse into our near future when we start talking about curried functions and partial application. It's not giving us an error. It should give us an error because reduce requires, for it to work, it requires 3 arguments. We've only given it 2. I'm just going to stick an argument in here. Now, why did that work? It's because actually, well, how do I start explaining this now? Tell you what, let's get rid of that. First of all, what we get back is effectively the same thing as what we had a minute ago. How about we do this? What is going on there? What is going on there? Now, what? So, first of all, let's just go back a few steps and have things work as we'd expect them to work. You know, look at the happy path rather than the random paths. So Ramda's reduced definition expects an iterator function, which is this function, which is this, add in this case. It expects, as Javier quite correctly points out, a value which is the starting value for the accumulator, for the value that we're going to end up with. But we've got to start somewhere. So obviously, if we're going to add things together, starting at something, so we take the first value, 1. We want to add it to the accumulator. If we want to add things up, then of course that accumulator needs to be 0. Otherwise, you know, the value is going to be. So if we started, for example, at, let's go down here, started at 10, then we get 25 because we start at 10, add 1, which is 11, then 11 is the value of the accumulator. And then we add 2 to the accumulator. 2 plus 11 is 13. The accumulator is 13. Then we add 3 to the accumulator, which 13 plus 3 is 16. Then we add 4 to the current value of the accumulator. 16 plus 4 is 20. And then we add 5 to the accumulator. 20 plus 5 is 25. Okay, but we, you know, obviously it makes sense when we're adding things up to start at 0. In fact, is there a multiplier function? Probably multiply. Multiplies 2 numbers. So if we were to multiply, right, this is a bit random, but if we were to multiply, is it multiply. We're going to get 0, aren't we? Because the accumulator starts at 0 and reduce iterates over each of the items in the third parameter position. So 0, and it says, and then it pass. In fact, let's do this. Let's write it out. So the first time around, multiply gets. Let's just copy that into my thing there. Multiply gets the current value of the accumulator and the value of the nth item in the nums that it's iterating over. Okay. By the way this Ramda things works is it'll just give us the value of the most recent, the latest thing. So let's just comment this out so to avoid confusion, right? Oh, that's not a comment in JavaScript. There. Okay. So so this is, you can see this is going to end badly because we're always going to get 0, and then that then becomes 0. So 0 is the value of the accumulator for the next value in the iteration, which is 2. So 2 times 0. So this is why we need to specify 1 here, right? 1 times 2 times 3 times 4 times 5 is 120. Okay. Now, what have we learned so far? We've learned so far that reduce actually takes 3 arguments. The iterator function. And I think that it's a good way of understanding what reduce is doing by referring to this function as the iterator function. Successively calling the iterator function and passing it an accumulator value and the current value from the array, and then passing the result to the next call. So you've got to, so basically this thing here, am I overdoing this explanation? Let me know in the chat if this is making sense. If I'm overdoing it, what? So, oh yes, one thing I mentioned in the previous episode was that reduce. The name reduce makes me, and I suppose everybody else, think of making something smaller. So reducing, for example, an array of multiple values to a single scalar value. I'll put my head down there. However, reduce doesn't have to do that, okay? What were to happen if we were to say, well, I want to start with an object. Now, of course, at the moment, we get not a number. Because object times 1 in JavaScript, surprisingly, or not surprisingly, given JavaScript, or surprisingly, is not a number. However, if I were to say, let's define a function, accumulate, let's just call them by the slightly longer terms. Let's just return a hard-coded value at the moment. Okay, so what is happening right there, 847, right there is exactly the same thing. We start with this base value, the initial value for the accumulator, which is an empty object. And reduce then calls this iterator function with 2 values. The value of the accumulator, and of course right at the start it takes the value of the accumulator from this second argument here. What are you starting with? So it's basically calling it with that and 1, right? And then well, at the moment, in fact, let's go back to the multiply thing, right? Multiply, let's get rid of that as well. Multiplying these 2 things together are going to give us not a number, obviously. And then not a number times anything is not a number. So then what I did, remember this, what I did was that, and all I'm doing is returning a hard-coded value, okay, 42. So whatever we pass in, we're going to get 42. So basically the accumulator is going to be 42, 42, 42, 42, 42. At the end, it's 42. So why don't we now, and that's a nice way of sort of building up what you want to do. So now we want to say, let's put it in here. So accumulator of value equals hello. Let's do that first of all, right? Return accumulator. There we go. We get 1 hello, 2 hello, 3 hello, 4 hello, and 5 hello. So we're building up an array. I mean, that's a bit of a stupid idea, but we could say, for example, is value to the power 2. So there, you see what we're doing there? There, we're not in a sort of a size sense reducing this array of 5 elements down to a single scalar value. we're actually reducing it to something slightly bigger, if that makes sense, which is an object where the keys are the original numbers here, the original values 1, 2, 3, 4, 5, and the values are the squares. Okay, 4 4s are 16, 5 5s are 25, etc. Notice that, it's sort of arguable what should be returned. If let's go back to here. If we were to say, for example, A equals array, empty object, and then if we were to say A of life equals 42 and run that, look what happened. REPL, hold on, RC, there we go. If I were to run that, what do you think we're going to get? What we get from the evaluation, from the execution of that, is unfortunately not the entire A object, but we get the value that was assigned. Okay, and because of that little nuance, that's why, let's make that a little bit smaller, that's why I had to have not only the assignment of the square of the value to the particular position in the object, but also I had to make sure that what was returned from this function, from this iterator function, is the new value for the accumulator, the entire accumulator. And in this case, the accumulator is the object. So we need to return. If I didn't do this, if I said, let's just comment that one out there. I'm not sure. Oh, what I expected. Oh, I've commented the whole thing out. Hold on a second. Let's do that. If I just did that, cannot create property 2 on number 1. There we go. So in fact, if I refresh that, we get that error. That other thing was just sort of, a ghost. Because 1 1's a 1. So the output of the output of this function call for the first iteration is we assign to the accumulator in the position 1 the value of 1 times 1, which is 1. But what gets returned from this expression, as we saw here, is not the whole of A, it's the value 42. So we get 1 as the accumulator back. So we suddenly go from an empty object to a scalar integer. And of course we can't, what it's trying to do here at this second stage is say 1, 2 equals 4. Okay, you can't do that, right? Does that make sense? Does that make sense? Oh my goodness me, 8:53. Let me know if you're still there. Are you all still there? Yes, you're all still there. Okay, you're all very quiet. Now, I want to leave you with one thing. Because either you're super bored or I've confused the heck out of you. So let me know in the chat which one it is or if it's something else. What I'm going to do now is go back. In fact, yeah, no, let's do something. Let's do one more thing, right? So let's get rid of that. Oh no, I've not got, how do I, there. Let's get rid of all this, there. Let's write a function. Again, small pieces loosely joined, composability. Let's build our own function. There might be a function in Ramda to do this, but it doesn't matter. Const get max is a function that takes 2 arguments. I like x and y better. 2 arguments, x and y. And this is a little bit sort of vague, but run with me here. If y is greater than x, then return y, otherwise return x. Okay, so if we say get max 10, 15, we get 15. 10, 5, we get 10. Okay, it's a stupid function. And let's say also our numbers here, this one here is 30. Now, how are we going to combine this nice function, get max, but use it on this array of values? We can't say get max nums because before I presented, I knew it was going to do that and thinking that's going to be really confusing. But, and the reason it's confusing is, let's not go there, let's not go there. That doesn't work, does it? So, what we can say, however, now we know how reduce really works. Can you see if we renamed, oh no, let's not rename it, let's just say reduce get max 0 nums 30. So Javier is saying, previous to this session, I was thinking that reduce was more for mathematical operations over arrays, but now I see more potential of this reduce function in different areas. Javier, great comment, yes. So the first thing to say is absolutely right. Reduce does iterate over arrays. So the main value type that it operates upon, or the value type that it operates upon, is an array, a list of things. But those things in that list don't have to be scalar integer values or scalar number values generally. And what reduce produces doesn't have to be some sort of scalar integer value that's been calculated through this reduce thing. We can process strings, objects, complex structures with reduce and produce other strings or objects or otherwise complex structures or other arrays with reduce. It's a generic iterator mechanism that is super, super powerful. So hopefully you can see now we understand how reduce generally works, is that it starts with, it iterates over a list of things. Each time around the iteration, it takes the thing that it's at, it's this one first, and it passes that value along with the accumulator, as in the thing that it's building, it's accumulating, to the function that you supply. So let's work through this. The first time around, it calls get max with 0 and 1, because 0 is the first, the initial value for the accumulator, and 1 is from there. Then, and that of course gives 1, because 1 is bigger than 0. And then it calls get max 1, which is of course there. That goes into, let me do that way. It's going to take too long to do some ASCII art. No, let's not do that. With 2. And of course that's 2. And then it calls get max 2, that one there, with 30. And of course that is saying, well, 30 is bigger than that. And so then it calls get max 30 with 4. That's 30. And then it calls, get max 30, because 30 is still the accumulator, with 5. 30. And now that's it. Then there's no more, there are no more elements in the array. So it says, okay, well, whatever the accumulator is at the end, that's what the answer is. Okay. Oh my God. Final thing. What happens if we were to say const the max equal, this is a ridiculous example, but let's do that there, like that, the max. So if we say the max, what is that? That's a function. The max of 5, 4, 5, 3, 88, 7, 74, etc. Right? 88. Now, what I've done here is I've partially applied, as in I've only given a partial set of arguments to reduce. And what happens when you partially apply a function? You get another function back that is waiting for the arguments that you haven't yet supplied. And therefore, we can build a function called the max, which is this partially applied reduce. And then we've got this function that just takes a single argument, which is this array, which then magically completes the argument requirement for reduce and calls the whole thing, calls this thing here, reduce get maximums. So I want to give you a taster of that because we're going to go dive into what that was all about, partial application and currying, in the next episode, if that's okay. So stare at that, understand what's happening there. By the way, note that all built-in functions in Ramda are automatically curried. Whereas if we were to say reduce here, what would it do? Undefined is not a function, okay? The reduce and any function in standard JavaScript and Node.js, there's no currying going on, okay? Right, that's it. I hope that was okay. There's a lot to learn here. There's a lot to share. So I'll stop there for now. Next, let's carry on this next Friday. Shall we do that? Recursion versus iteration. Yeah, we'll cover that as well. Yes, definitely recursion. I want to do recursion a bit later on. I want to sort of cover composability, but before composability, we want to talk about currying and partial applications because they are building blocks for composability. Have a great Friday. Have a great weekend, and see you next Friday. Bye for now.